Okay students, in this present video we are going to learn about the concept of the force. As you learn that force is that which changes or try to change the position of the body. Around us we will find number of forces. Okay, we talked about them earlier. Now we are taking the reference of electromagnetic forces and we are going to analyze them. While we are talking about the electromagnetic force, here one force is very important. It is always with us while doing the problems and as well as the applications. One such force is normal force, students. One such force is the normal force. Is the first force. The second one is the tension. These are the two important forces. Here these two forces are electromagnetic forces only. Okay, first we have to know about what is the normal forces. I told you it is a contact force. When the two surfaces come in contact with each other at a point of application, a force acts, we call it as the normal force. It can be shown very easily. I said it is the electromagnetic force. Why we call it as electromagnetic? It is due to the interaction between the atoms of the body. That's why we call it as the electromagnetic. See, we are talking about the normal force now. Let's take, it is a surface. For our understanding, we are calling it as a plane surface. Okay, and we kept a body here. It is in the shape of a block. Okay, it's the block which is kept over a surface. And here it is the center of mass of the body. In coming classes, you will understand what is meant by the center of masses. Just I will give a definition for that. It's the point where the mass of the body is supposed to be concentrated. Okay, here it is the body which is kept over a surface. Then immediately we have to remember the third law of Newton. It is stated like this: to every action there is equal and opposite reaction. Simply we can say action and reaction should act on two different bodies. Action and reaction should act on two different bodies. To every action there is equal and opposite reaction. Here this body is kept over a surface. Then what happens here? It causes a force on the body. Okay, this is the force which is caused by this body over this surface. Let it has a mass of m. Okay, this force is working towards the center of the earth, and we know that this force is gravitational force, or immediately we can say it is the weight of the body. The weight of the body is causing some force on this surface. It is the action. According to Newton's third law, to every action there is equal and opposite reaction. That means action and reaction appears in the form of pairs only. You cannot get both action and reaction on a single body. Action and reaction might act on two different bodies, and also they are equal in opposite. Here a force will act vertically downwards. Let's say it is the weight of the body, and you learn that weight is nothing but the force with which a body is attracted towards the center of the earth, and this mass is causing some force on this body. Immediately this body, the surface, responds to this action. Okay, and it is the direction of the reaction. Okay, call it as N. N is the reaction, or you can say, you can show it like this. If it is the surface, the body is kept, weight of the body is acting in this way, it is action, and immediately force will act in an opposite direction, and it is the reaction. If you watch it carefully, you will understand the reaction force is in opposite direction to the weight of the body. See this? It's the action and it's the reaction. And see, the two are acting on two different bodies. It's the surface and it's the body. Okay, students, it's the reaction. Reaction, we call it as the normal force or normal reaction. Normal force can also be told as normal reaction. See? In the same way, if you watch one more body, it is the surface. I said it is AB, is the surface, and body is kept over. Here in this case, N is equal to mg. Okay, just think, we are taking an inclined plane. Is the inclined plane. Making an angle of theta with the horizontal. It is the inclined plane. Let us know about the normal reaction. The same block. See, I am keeping this block here. Okay. It has a mass of m. And we have to find out what is the normal reaction is. How to get the normal reaction. See, as usual, it is the center of the body. And the weight of the body acts vertically downwards. We call it as the weight. Weight is equal to mg. Okay, students. The normal reaction. It is the normal reaction. Normal reaction always acts perpendicular to surface. It's a normal reaction. See this, it is not normal to the weight, but it is the normal to the surface. You watch it clearly, you will find the normal reaction is normal to the surface. But here you see, the weight of the body always acts vertically downwards. That's why don't mistook was that the weight and as well as the normal reaction are perpendicular to each other. No, not at all. It is possible in only one case. When the body is kept over a smooth surface or a horizontal surface, the weight and as well as the normal reaction are perpendicular to each other. Normal reaction deals with the surface on which the body is kept, and it acts perpendicular to the surface on it is kept. Understanding, students? In that way, we can find out the normal reaction. Here, if you go further, we can find out the magnitude of the normal reaction, and you know it very well. Just resolving this quantity, normal reaction, okay, and as well as the weight of the body, we will get the magnitude of the normal reaction. As you know, that is mg, and here it is theta. It is equal to this, and resolving weight into components. Okay, here it is mg cos theta. You know that the thing which is further down the theta is always mg cos theta. Here we need mg cos theta, and it is the mg sin theta. Here it's not required here. We are finding the magnitude of the normal reaction. Then you can write N is equal to mg cos theta. It is the normal reaction. Here is a plane surface. Normal reaction N is equal to mg. You can check it. It is the theta. Here keep the theta as 0. Here see the angle between the two. Then what do you get? Cos 0 is equal to 1. N is equal to mg. It is the normal reaction, students. You have to remember that normal reaction acts perpendicular to the surface only. It is not at all related to the weight of the body, but it depends upon the normal reaction. That means what? Surface. The next thing we have to know about what is the tension is. Obviously, tension is a force. Okay. Generally, we show this term tension in case of a suspended pulley or a string from a rigid support. Whenever we talk about the spring, we call it as an inextensible and massless string. That means we are not at all considering the mass of the string while we are measuring the tension in most cases. Okay, students, let's say it is a rigid support. What is a rigid body? Here you have to understand why we call it as the rigid support. It is the surface, okay, which cannot get deformed by the application of the external forces. Such kind of surface is rigid surface. Or simply we call a body as a rigid if it doesn't undergo any kind of deformation, that means change in state, when forces are acting on it. Generally we take a iron bar is a rigid body. Okay, here it is a rigid surface from where we suspended a string. I told you it is inextensible and massless string. It is inextensible and massless string. Here by suspending it and we are hanging certain mass from the other end of the string. Okay, students, if you watch it clearly, the weight of the body acts vertically downwards. We are using the same third law. Then immediately a force will develop, okay, against the weight of the body, and it acts in this direction. We call it as the tension. Okay, actually what's going on here? This force is trying to extend this body. I told you it is the massless and inextensible body. Then immediately other force develops which tries to compress this string which is going to be extended. That compressive force is nothing but the tension, and you have to remember that tension always acts, what is that, opposite to the point of contact. Here we get the tension force, and here also we have the tension. It is a contact, it is a point of contact which is away from that. Okay, simply you can understand this thing very easily. Just hold an umbrella and open it. Okay, the cloth of umbrella will move forward. In the same way, here think it is an umbrella. Okay, here we kept a umbrella. Okay, we are finding the tension. If you open up here, or simply say it is the umbrella which is kept here, and if you open up, immediately it will move upward. This is the direction of the tension. The same thing will happen here. If you hold this, and it will move in this way. And the point is, what we have to remember is the tension force is a force always acts away from the point of contact. That's why we are showing two tensions in opposite direction. Okay, here it is a compressive force. Here, say this. Okay, it is always acts away from the contact. It's the tension force, students. Okay, I hope you understood what is the normal reaction and also what is the tension is. The next part of this is, what is that, to draw AFBD. FBD. It is very important to solve the problems. What is the FBD? It is the free body diagram. It's a free body diagram. Okay, what is the free body diagram? It's a diagram which shows the number of forces acting on the body. To draw the free body diagram, we must consider the body as a point-sized body. Even though its dimensions are high, we consider it as a point-sized body, and taking that point-sized body and will show the direction of the forces. Let us analyze the free body diagrams. I already told you, free body diagram is the representation of forces acting on a body by considering a point only. Okay, let's say it is the body which has a mass of m being suspended from a rigid support. Okay, and the center of the mass of the body and the weight of the body is acting vertically downwards, and you know that it is the tension. The tension acts away from the point of contact, as you know. If you consider it as a point-sized body here, then it is the weight, obviously the weight which is acting vertically downwards. Okay, and we have to represent the tension. Is the tension is a free body diagram. Okay, weight is acting vertically downwards and the tension is in upward direction. Let's see one more diagram. Is the body which has a mass of m being suspended by a string. As you know that it is a pulley, and is the direction of the tension, as you know that. Okay, and also it is, and here is the tension, it also is the tension, and it is the weight of the body which is acting vertically downwards. We have to draw the free body diagram. Okay, we are drawing the free body diagram for the mass of m, and consider it is the block which is kept over a surface has a mass of m. Okay, here if we consider it as the mass, the weight works vertically downwards and normal reaction will be up. Okay, and see, this is the mass, okay, which is in contact with this. It is the normal reaction which is acting. Is a normal reaction. Let's say this normal reaction is m1 and it is mg and it is m2. Okay, if you draw the free body diagram for this mass, okay, for this mass we are drawing, what we will draw? Say this is the mass of the body which is acting vertically downwards. Okay, see, it is equal to mg and normal reaction, I said n1, and we need to find the normal reaction. See, it is n2. I am taking the reference point. Is a free body diagram. Additional to that, this body is connected with the tensions. Then here we had to add the tension here, T plus mg and 2. Okay, and was this one is acting vertically downwards, and it is added with T. Is the free body diagram of this body. Similarly, you can draw the free body diagram of this one. Consider a point mass here. Its weight is acting vertically downwards as mg. And see, it is a normal reaction. Say it as N2. And additional to that, we have a normal reaction here. Here this weight is acting down, and we have to show the normal reaction N1. Right? We can call it as the N1 dash. Is the free body diagram. Understanding, students? In this way, you can draw the free body diagram of any body. Here, N1 dash is nothing but tension. Put it as the tension. See, this is the tension which is acting on. Here, normal reaction is nothing but the tension. For this mass, it is the free body diagram. For this, it is. Okay. Here in this way, you can draw the free body diagram of any body. And obviously you know that if you go towards the inclined plane, I already mentioned you can draw it very easily. Okay, it is the mg. It's a normal reaction. Okay. If you consider it as a point, then you can draw the free body diagram very easily. Obviously it is mg cos theta. That means what? If we draw, it is normal reaction and it is mg cos theta. In this way you can draw the free body diagram, students. Okay, I hope you understood what is the free body diagram. It is the representation of the forces acting on the body.